Fuses have been around since the 19th century, and they're still part of the grid. Fuses are designed to blow whenever there's a strong power surge. This stops the flow of electricity and prevents electrical fires. So by handling power overloads, fuses also take a big load off your mind. Choosing the right fuse depends on your current needs. To make a high-voltage fuse, this machine cuts notches in a long silver strip, which will serve as its element. The notches will help control the way the fuse blows. They melt bits of soft metal onto the strip. The bits will be the points where the fuse blows. They weld one end of the silver element to the top of a ceramic core, and then wind the element around it. This kind of high-voltage fuse will be used in electrical substations. They slide the element core into the fuse casing and bend back metal taps. Then, using a soldering technique called brazing, they seal everything together. They take a brass washer and wind ignition wire around it. They're assembling the striker pin, the device that indicates a blown fuse and shuts down the power. They press fit the striker pin to the washer, and with the wire protruding, place it in a holding device. They add explosive powder to each striker pin. Then they plug the bottom of the pin with a rubber stopper. Then they press the striker pin into a brass capsule, which will contain the mini explosion that pushes out the pin when the fuse is blown. This test run shows how it all happens. They wrap the pin's ignition wire around an electrical post. They clamp down the pin and position the pendulum that swings to indicate the amount of force with which the pin fires. A jolt of power detonates the explosive. This causes the pin to protrude, signifying a blown fuse. Now they slide a metal eyelet onto the striking pin's ignition wire, and then attach a wire coil to it to complete the ignition system for the striker pin. Using a snare, they pull the whole assembly into the fuse. They tie the end of the coil to the fuse's cap. And they press fit an outer cap over the inner one. They fill the fuse with a specific type of sand. It's a filler that absorbs energy from the element when the fuse blows. Automated rods tap the fuses to compact the sand inside. Next, they lubricate an outer cap for the other end of the fuse. And they press it onto the fuse. This machine spins grooves onto the cap, pinching it lightly to the fuse casing. They run a current through each one of these fuses, checking the voltage throughout to confirm that it's in good working order. They pump sealant around the rims of the caps to make them completely airtight. Finally, they affix the safety information and stamp specifications onto the caps. Now these fuses are ready to go with the electrical flow. And if there's trouble, they'll blow.